So hi guys, I am Rosamund Ginha from IT2103. So welcome to my channel. So from this vlog, which is we have to do a tutorial about this chapter, which is the IP addressing. So again from the IPv4 network addresses. So in this chapter, we have to apply all the knowledges that we have were done that were done tackled in the chapter 7. So about that, we have to answer all the activities from this chapter for us to know the limit of our knowledge for this chapter. So let's start. So first, from the activity 7 or activity chapter 7, from the first activity, which is the binary to decimal conversion activity. So this activity allows you to practice 8-bit binary to decimal conversion as much as necessary. We recommended that you work with this tool until you are able to do the conversion without error. Convert the binary number shown in the octet to its decimal value. So from this activity, we have to occupy the decimal value, which is we have to add this. For example, from this bit, which is 0000111. So from the bit that has a 1, we have to add him from its position, which is 4 plus 2 plus 1 is equals to 7. So the decimal value of this bits is 7. So let's check. So it's correct. So from this activity, when we are searching for the decimal value of this bit, so this our final answer is 7. So let's do the next activity, which is so from the activity and ending to determine the network address. So use the ending process to determine the network address in binary and decimal formats. So we have to answer this network address in binary and the network address in decimal, which is, let's answer. So from this one, 0001, then 1101, 01, then 00. Tama ba? Then the next one is this. So from the network address in decimal, 10, then 209, then 191, so this is the answer for this activity. So let's do the next activity, which is, so from this activity, unicast and broadcast or multicast. So click start to view the destination IP address, then next click the host, which will receive a packet based on the address type. Unicast, broadcast, or multicast. This is a timed activity. So from this activity, we have to do what, for example, an IP address will pop up in this blank. So we have to select APC that will receive the IP address from here. So let's start. So 192.168.110.2. So this, let's see if it's correct. Then you have successfully identified the transmission type. So let's try again. So this will be the two pieces. So you have successfully stop. So let's proceed to the next activity. So the next activity was activity pass or block IPv4 address. So the instruction, decide to pass or block each IP address depending on whether it is public, the internet, or a private small local network. So click start to begin and click on either pass or block. So start. Pass. Then pass. Pass. So from this activity, they have an IPv4 address which is pop on this side, and you will decide if you pass or block the IPv4 address. So let's start, or let's begin to the other activity, which is so from this next activity, which is public or private IPv4 address. So drag each IP address to the correct category if it's public or private. So we have to drag from this side if the IP address is public, and from this side if the IP address is private. So first, this 172.2 will be on the private, and this 192 will be on this private too. And the 192.0, 0.3, and 0.15 will be on the public. This 64.104.0.22 is for the public, and this 209.165.201 and 0.30 will be here in public, and this 192.168.11.5 will be here in the private, and this 172.16.30.30 will be here in private, and this last one is also in this private. So let's check. So all the IP address that I've dragged in the public and private are correct. So let's begin to the other activity, which is from this activity, which is IPv4 issues and solutions. So drag the IPv4 and IPv6 terms to the field next to the appropriate description. So the 128-bit address and 340 undecillion addresses. So from this description, it is IPv6, because IPv6 has a 128-bit address and 340 undecillion addresses. And from this 32-bit address and 4.3 billion addresses is IPv4. We all know that IPv4 and IPv6 are not the same because IPv4 has only a 32-bit address and the IPv6 has 128-bit address. So from the third one, which is tunneling has a transport an IPv6 packet over an IPv6 networks. So from this uses NAT64 to convert between IPv6 and IPv4, which is the answer is translation. And from the fifth one, which is allows IPv4 and IPv6 to coexist on the same network segment, which is the dual stack. So let's check. So it's correct. So let's proceed to the next activity, which is from this activity, which is practicing IPv6 address representation. From this activity, you have to convert the IPv6 addresses into short. So omit the leading zeros and compressed forms. Use the numbers at the bottom of the page to continue this activity. So let's answer. So from the preferred format, which is 2001, from the omit leading zeros, we have to copy the numbers, which is 2001. And when the preferred format was 0, you have to answer this as 0 only. And this from ODB8, you will not include this 0 from your answer here, which is you have only answered this DB8. And from this one, which is 111, and this, from like this, you only type 0, then 0, then 0, then from here, 200. Then, when you are done from this, you have to compress this format from the omit leading zeros, which is 2001, then this, then 0, then DB8, then this. So 111, then this. So if this is all zeros, you only have to write here and another like that, and proceed to the next number, which is 200. So let's check. So my answer is correct. So let's answer all of this activity. So from here, 20, 13, then 0, then 1, 2, 3, then 4, 5, 6, 7, then 8, 9, 8, 9, AB, then C, D, F, D, E, F, then 0, then 1. So let's compress format this omit leading zeros, which is 20, 13, then this 0, then 1, 2, 3, then 4, 5, 6, 7, then 8, 9, A, B, then C, D, E, F, then 0, then 1. So let's check. So as we can see, I am wrong. So let's see what is, oh, I have mistaken this. So let's check. So correct. So the next is 0, 0, 0, 0, 0, 0, 0, then 1. So from this quotation and this one. So the next, which is 2012, 2012, then A, B, C, A, B, C, D, then E, F, 0, 1, then 2, 3, 4, 5, 2, 3, 4, 5, then 0, 6, 7, 8, then so you have, from this preferred format, you don't have to add this 0, just 6, 7, and 8, then next 9 and 10, then next the A, and B, and B. Then let's compress this format, which is 2012, then A, B, C, D, then E, F, E, F, E, F, then 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5, then 6, 7, 8, then 9, 10, then A, and then so this is the answer. So let's answer this one, last one, because all of this activity are the same. So let's answer this as a last, which is A, B, 1, E, then 2, B, 0, 0, then 0, then 1, 2, 3, 4, then 5, 6, 7, 8, 5, 6, 7, 8, then 9, 9, 1, 0, 1, then 1, 1, 1, 2, then 1, 1, 1, 3. So let's compress this format, which is A, B, 1, E, A, B, 1, E, then this, then 2, 2B, 0, 0, 1, 0, then 1, 2, 3, 4, then 5, 6, 7, 5, 6, 7, 8, then 9101, then 1112, then 1113. So this is the last, and this answer is correct. So let's proceed to the next activity, which is, so from this activity, which is activity, identify types of IPv6 addresses. So from the instruction, drag the IPv6 address type to the most appropriate description. So from this description has a unique internet and routable IPv6 address, which is dynamic or static. So I think it is global unicast, because global unicast has a unique internet routable IPv6 address. Then from the FE801, it is a link local. Then the 2001 BB8 and AHAD that 1 to 64, it is a global unicast. Then from the typical IPv6 prefix used to indicate the network portion of the address, it is a 64. So from the use to communicate with other devices on the same IPv6 subnet, which is the link local. So let's check. So all the answers are correct. So from this all activity from the chapter 7, we are able to identify all the knowledge that all the knowledge that we are learning from reading from the NetAcad. So that's it. So thank you for watching, and bye.